Good morning, good afternoon. Here we go again with another video, 1.3, multiplying and dividing monomials. At the end of today, we should be able to simplify expressions using those laws of exponents. We're going to get into a few different rules. Remember to pause the video while you are filling out the notes and then go through those examples with me. Everything I say, remember, is very important, and you should be listening, not just writing that whole time. So it's very important that you do pause the video while we are taking those notes. So here, pause the video, write them down. A monomial is going to be a number, a variable, or a product of one or more variables. So an example, this is not just a big long, think of these really separately. 4, just 4 is a monomial. Okay, an x, a term or a variable, is just the x is a monomial. Mono means one. This 3x is a product of one or more things. 3 and x, they're right next to each other, so that means multiplying. And then here again, color, 12m cubed is a monomial. Okay, properties of exponents. You can identify which property of exponents to use, and if the expression involves both numbers and variables, always evaluate the number portion as far as possible. When you have variables, variable is just a letter that is representing something at some point. Okay, so x is just representing a number, and if you just have x like this, that's as far as you can go. 3x. You can multiply numbers, right? But you can't multiply it if you don't know what that number is. So 3x is as far as you can go. Now if I have 4 times 3, I can multiply that. And you can do that as far as possible. Okay? So here, I'm going to get onto my course. We have a cubed times a squared. Now if I look at that, I can write that out as a times a times a. We learned that, right? And we could write this one out as a times a. Now if you notice, they're all multiplying. So now, don't even look at this. Look at this new problem. I have a times a times a times a times a. So I'm going to actually rewrite this as a times 1, 2, not times, sorry, 1, 2, 3, 4, 5, to the 5th power. Now, knowing that, that's going to come into our first rule, our product of powers property. That means that if I'm multiplying powers with the same base, remember that base is my a here, I can just add their exponents. It's kind of a shortcut way. So a to the m power, this just, again, these are just letters that are representing a number right now. These are almost generic. They're saying any number raised to a whatever power, and if it's the same number multiplying to a different number or the same number, what I can do is I can add the exponents. This is actually m plus n. I kind of wrote it kind of close together. So here, a to the third times a to the second, I'm going to just write it as one base. 3 plus 2 is 5. Done. This is as far as I can go because a is representing a number that I don't know what that number is at this point. Okay, so if they just ask me to write it as a power, I would write 9 to the 5th power. But now if they ask me to evaluate it, then I'm going to actually evaluate it and do 9 times 9 times 9 times 9 times 9. So 81, here's 81, and then times another 9. And 81 times 81 is 6,561, and multiply that number times 9, I get 59,049. Okay? Here, this is all multiplying, so there's nothing on the outside of these parentheses, so I can rewrite this as -2 times a -8 times m to the 5th. So now I kind of can see that I can actually do this problem, -2 times a -8. So negative times negative is a positive, and 2 times 8 is 16. Here, m, this is really raised to the first power. So I have to remember that this is not just going to be m to the 5th power, it's actually going to be m to the 6th power, because I can't forget this m here. Okay, I cannot do anything else. This m is being raised to the 6th power. There's no other operations of multiplying, dividing, adding, subtracting that I can do. So that's all I can do there. So what I'm left with is 16m to the 6th power. This should be 6th power. It should look more like a exponent. Okay, so now think about x to the 10th power. We're going to write that all out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then x to the 3rd power times x. Now, if I have a number on top and bottom of a fraction, that equals 1. So this x divided by this x, doesn't matter what that number actually is. Anything divided by itself is 1. So they cancel out. Same with this one and this one and this one and this one. And so now I only have 1, 2, 3, 4, 5, 6, 7 left, which is actually x to the 7th power. And that comes into our next rule of if you have quotients of powers, meaning I'm dividing. If you to divide powers with the same base, subtract the exponents. So again, m minus n. Whatever number, if I have the same number on top and bottom and they're raised to powers, I can just subtract those powers. So like here, I can just do 10 minus 3, which equals x to the 7th power. Here, 7 minus 4, that same base, but now it's raised to the 3rd power. Now x to the 7th, I can't go any further, but 5 to the 3rd power I can. I can work this out to be 5 times 5 times 5, and I can do 5 times 5 is 25, times 5 is 125. Now, if I actually did 5 on top, 5 times 5 times 5 times 5, 7 times, right, it would get me a really, really big number. And then 5 to the 4th power, again, would get me a big number. And if I divided this big number by this big number, I would still get 125. It would just be a lot more work. Okay, so the next one, 12 and 2. They're not like bases. I'm not going to, subtract their exponents because they don't have any, and 2, they're not like bases. But I can divide them, can't I? 12 divided by 2 is 6. And then here again, I don't have an exponent. So if I don't have an exponent, it's always going to be 1. So w to the 5th power, so w 5 minus 1 is 4. So my final answer is 6w to the 4th power. So here, we have numbers now, and we can work them out, but there's going a long way. Like we can multiply 3 times 3 times 3 times 3 times 5 times 5 times 7 times 7. We could do all that. It's just going to be a lot more work. So we're going to actually simplify using those rules first that we just learned, and then we're going to multiply it out, and it's going to be a little easier. So here, 3 to the 4th power, 3 to the 2nd power, those are those like bases of 3 and 3. So subtract the 4 minus 2, I get 2. And then 5, remember here, is a 1. So it's 5 to the 1st power. And then I have 7 to the 2nd power. 3 to the 2nd power, or 3 times 3 is 9, times 5 times 49. So then I have, I'm going to do 45 times 49, and I'm going to get 2,205. And that's my answer. I don't have enough. I would go and do all these out because there would be really, really big numbers, but I don't have enough time on my video. So if you want to try it that way and see the difference, you should be getting the same exact answer. It's just going to take a little bit longer. So here, 5, same base, 6 minus 4 is 2. So here, if I look, I have like bases on top, so I'm actually going to combine my like bases first. So skip that part. I want to do 8. I want to combine these first. So on top, I'm going to still have that 5 to the 6th power times 8 to the 7th. Remember, because I'm multiplying them, so 4 plus 3. And then on bottom, I have these two like bases. So it's 5 to the 6th power times 8 to the 2nd. Now, 5 to the 6th power divided by 5 to the 6th power, these are the same exact thing. So those go away. And then I have 8 to the 5th power, and I'm going to multiply that out. So it would be 8 times 8 times 8 times 8 times 8. And it gets me 32,768. Now again, remember we're talking about showing your work. You want to show this work. I did use a calculator to find this. I don't expect you to multiply it out every single time. But when you can, if there's smaller numbers, say 9 times 5, we should be practicing that. Or do it in your head, write 45, and then check it on a calculator. That's one of the best ways that will teach you, or you could practice those just multiplication facts. Okay, here I want to double check that I don't have any of the same bases on top or bottom, because over here like I did. So here I'm going to do -2. 5 minus 2 is 3. Remember, I don't have a exponent, so it's just going to be 1. So it's going to be multiplied 3 to the 4 minus 1 is 3. And then I have 5. 7 minus 4 is 3. So -2 times -2 times a -2. -2 times a -2 is 4, times a -2 is a -8. Sorry. Then 3 times 3 is 9, times another 3 is 27. So multiply. And then 5 times 5 is 25, times another 5 is 125. Again, I'm going to take my calculator and do a -8 times 27 times 125, and I get a -2,700, or 27,000, sorry. Okay, remember, if I have a negative here and no other negatives, your answer will be negative. Okay, here, I have numbers and letters, so I'm going to write them so that all my, group them together. So a 3, because it's all multiplying. -6. Then I'm going to do the A's. And then the B's. And then the C's. And the only really I can combine these letters, right? And these I can do that out. So 3 times -6 is a -18. 5 plus 2 is 7. 7 plus 9 is 16. C to the 6th power. Done. This is as far as I can go with those variables. Same here. 5 to the 4th power. So I have 5 to the 3rd power. M to the 2nd. Running out of time. Sorry, I'm going fast. This can be worked out to 125. M to the 2nd. M to the 1st. A minute and a half. Okay, total shoreline is 2 to the 10th power miles long. New Hampshire shoreline is 2 to the 7th. About how many times longer is Hawaii's shoreline than New Hampshire's? So that's going to be 2 to the 10th divided by 2 to the 7th. So I'm going to do 2. 10 minus 7 is 3. So it's 8. So it's about 8 times longer. All right, your assignment right here is page 27, numbers 1 through 21 odd, 27 through 31 odd, and then 35. Remember to do it on a separate sheet of paper.